Welcome to STEM Space at Home, a series of engineering design challenges for all ages that you can do right at home. I am Claire, I'm an aerospace engineer and your guide for today's challenge, plants in space. So first we're going to start off with some trivia questions. I'll test your knowledge of plants and growing them in space. Then we'll learn some science and finally get to do an engineering design challenge where you can build your own device to grow plants anywhere. Let's get started. Right now, NASA is planning on sending astronauts back to the moon with a program called Artemis. Not only will astronauts step foot on the lunar surface again, but the Artemis program will also establish a lunar outpost called Gateway that will orbit the moon. This is a huge step for the possibility of eventually having humans live on the moon or even Mars. So here's a question for you. Astronauts currently aboard the International Space Station are provided about 4 pounds of food per day. That's roughly about 4 cans worth of food that they need to eat each day. So the trip to Mars will take about 5 years. So your question is, how many cans worth of food per astronaut would need to be packed aboard a rocket for them to make the whole round trip to Mars? Is it 100 cans worth of food, 1,000 cans, or 7,000 cans? One astronaut would have to bring 7,000 cans worth of food for a 5-year trip to Mars. That's a lot of cans. That is a lot of weight to take on a rocket. Now, as you can imagine, more weight needs more fuel, and roughly about 90% of the mass of a rocket has to be fuel. So if you take 7,000 cans worth of food, all of that weight per astronaut, that equals a lot more fuel and a much bigger rocket, which gets pretty expensive. So we need a better solution. One possible solution is to grow plants in space. This can provide a multitude of benefits. One, plants can provide food for the astronauts to eat. They also work like mini oxygen factories, producing fresh air for them to breathe, and they can even purify water. Vitamin deficiencies can be a big health problem for astronauts too. And simply packing a bunch of multivitamins will not be enough to provide a healthy diet for astronauts during deep space missions. They'll need fresh produce. Have you ever grown plants in a garden before? Let me show you what I'm growing in mine right now. Here you can see my garden where I'm growing lots of different fruits and vegetables here. You can see that in this one I have lots of different kinds of plants coming up. I have onions, and this is broccoli. You can see a little broccoli growing in there. And there's some asparagus and spinach. Over here, there's some tomato plants and jalapeno peppers. And you can see that they are planted in really good soil where they get lots of nutrients. And then there's hoses here that let them have water, and they get plenty of sunshine to help them grow. That brings me to my next question for you. Which of the following things do plants need to grow? Is it sunlight, water, carbon dioxide from the air, or soil? The answer is everything except soil. See, plants take in carbon dioxide from the air and then put out oxygen that we breathe in a process called photosynthesis. This is how plants create energy for themselves. So while plants do get a lot of the minerals that they need to grow in the soil that they're grown in, they don't actually need soil to do it, which is a great thing because as far as we know, Earth is the only place that has fertile soil for plants to grow. Soil is also really heavy to transport, so that's not really a good option for us to bring soil into space. We're going to need a better way to do it, and we'll discuss that in a minute. But first, my last question for you. Who is involved in coming up with how to grow plants in space? Is it a botanist, an aerospace engineer, or a gardener? Let's hear the answer from Mark Watney from The Martian.
So, I gotta figure out a way to grow 3 years worth of food here on a planet where nothing grows. Luckily, I'm a botanist. Mars will come to fear my botany powers.
That's right, botanists study plants and how they grow. They're the people that will help design a system that can grow plants in space. There's also another type of STEM professional called a payload integration engineer. They're the people that talk with the botanists and find out what plants need to grow in space, and then build the systems and machines and devices that will actually accomplish the task. NASA has already begun growing plants in space, like these zinnias grown by astronaut Scott Kelly aboard the International Space Station. They also grow plants for food in a system called the Vegetable Production System, or veggie chamber. How do they do it? They sow seeds onto a plant pillow that provides fertilizer and water for the plants to grow. Then they are placed into a chamber that acts like a miniature greenhouse. A greenhouse is something that we also have here on Earth that protects plants from extreme temperatures and weather. This chamber does not have soil. Like I said, the seeds are sown onto a plant pillow that provides fertilizer and water. The water is given directly to the roots of the plant in a method called hydroponics. This method has shown that the plants will grow 30 to 50% faster and produce more fruit. Sounds like a pretty good method. So, have astronauts actually eaten these plants in space? Yes. The first plant that they were able to eat aboard the International Space Station was red romaine lettuce. They have grown other plants too, like onions and beets and all sorts of plants, but mostly vegetables that act more like a pick and eat salad bar. So how would you like to build your own device to grow your own plants that can be planted anywhere? Let's get into our challenge. For your first activity, you'll be creating a mini greenhouse to grow plants like they do on the International Space Station using hydroponics instead of soil. To do this, you'll first need some tap water, a Ziploc sandwich bag that zips at the top, some cotton balls that will act like the plant pillows in the veggie chamber, and some seeds. Now for the seeds, you can use anything from, these are pinto beans, dried pinto beans that you have to soak overnight first. You can use popcorn kernels. You can use any kind of vegetable or flower seeds. You can even use dandelion seeds from a dandelion flower that you can find outside in your yard. Whatever seeds you use would work just fine. I would get more than one of them so that you can test them. Now the first thing that you're going to do is you're going to take your cotton balls, which are your plant pillows, open your Ziploc bag, and drop your cotton ball into the water. Now don't squeeze it out, but you can let it drip a little bit, and then put it into your bag. Now I'm going to do 2 seeds per bag, just to make sure I have something that grows. And then you want to take your seeds and put them onto your plant pillow. Now don't squeeze the air out, but you want to seal the top of your bag. Make sure that there's plenty of air inside. Now you have a mini greenhouse. Do you remember what the things that are needed to grow a plant? With the cotton balls, you have water that's going to grow your plant without soil, hydroponically. You have your seeds. Your seeds also have access to the carbon dioxide, which is in the air in your bag. And now they need sunlight. So what you can do is you can tape your mini greenhouse to a window that gets plenty of sunlight to watch them grow. Now keep a journal so you can track how many days it takes for your seeds to start growing. And then you can measure the height of your plant as each day progresses. Now here's your engineering design challenge. You want to be able to support your plant as it grows. If you don't attach it to the window, it won't be able to stay supported by itself, and then your plants won't grow. So another problem is that maybe you find that the window that you attached it to doesn't get the best sunlight, or maybe the windows in your house only face a certain direction. The sun rises in the east and sets in the west. So if you plant your plant and put your mini greenhouse in a window that's in the east, it will only get sunlight in the morning. You'd need to move it to a window that faces west or another direction in the afternoon to get enough sunlight. So how are you going to do this? Your mission is to build a device that will be able to support your plant so that you can move it if you wanted to. Just like the veggie chamber on the International Space Station can support the plants growing in it while it zooms around in space. So, how can you do this? First, you need to find some supplies that you can build a structure that will support your plant. You want it to be about 6 inches off of the ground and be able to support it from the sides or the bottom or the top. You can use things like cardboard from like a cereal box and make a structure. Or maybe you need paper cups or water bottles. Look around your house and first get ideas of how other things are supported to stand on their own. Look at picture frames. How do picture frames stay up? Or maybe look at a lamp and see how its base allows it to be supported. Use ideas that you see around you to figure out how you can best support your plant and create a device that will hold it where it can get enough sunlight. In summary, create your own miniature greenhouse to grow plants without soil inside your home. Then use the engineering design process to design a device to support your plant and be able to move it to the best place for your plant to grow. In the engineering design process, you first want to identify the problem. You need to build a device to support your plant. Then brainstorm solutions by looking at other things around your home that supports itself. And look at the materials that you have available, like cardboard, cups, things that you can use to build your own device. Next, create your design. Draw up a plan of how you want your device to work and how it will look using the supplies that you have. And lastly, you want to build it. Build your device and test it by adding your window greenhouse to your device and see if it is supported. Share your solution. We want to hear what you've created. Please post pictures of your creation to our social media channels on Facebook, Instagram, or Twitter using the hashtag STEMSpaceAtHome. We can't wait to see what you've made. And one day, maybe engineers will use your design to create a way to grow plants in space and maybe on the moon.